Today, it is my pleasure to introduce two presenters. With us, we have Mats Norlund, who is the CEO and founder of NetRounds, and we also have Stefan Wallin, who is a product management cloud and virtualization group with TLF, which is a Cisco company. Now, let's get into what we're going to be discussing today. For the presentation, we're going to be going through 5 sections. First, we're going to talk about the problems and opportunity. Then we're going to go into the design principles, the service modeling and test design, solution and building blocks, and summary. So we're really looking forward to dive into this content. Without further ado, I'm going to hand it over to our presenters.
Thanks a lot for the introduction, Lindsay. My name is Mats Norlund from NetRounds. Good morning, good afternoon, and good evening to everyone here, wherever you are in the world. So the first part here in this webinar, we will examine the underlying pains and the problems that was the starting point for us in the PoC team when we initiated the work earlier this year. And we will also have a look at the overall goals. So let's start by breaking down the steps involved in delivering network services today. If you start from the left-hand side, first the customer orders. The customer orders the service, then the device configurations are provisioned, and I would say only in some cases the circuits are activation tested to complete the fulfillment phase. In many cases, the delivery would now be considered as done, and it now becomes the assurance team's responsibility to supervise the service as it goes into production state. A worrying fact for many network operators is that it often takes weeks or even months to go through all these stages, especially if a new service is being launched. So a top priority for operators is to streamline this flow in order to have the design and delivery much more rapid. But there is a small catch here, and a major challenge is that the workflow that we see here is tightly associated with an underlying network that is very static in its nature, and the rate of change is I would say, very low, and it also involves a lot of manual work. So I think all of us here at the webinar today, we realize that these facts are pretty much the opposite of where we are heading towards with software-defined networks, where everything is going to be expected to happen at a much more dynamic pace and being fully automated as well. So we clearly see some innovation need to happen here to enable this transformation. And the first 2 steps, if you look at this workflow, the first 2 steps has gained a lot of industry focus recently, but the last 3 steps have been lacking behind. And that is where we started off the work in ETSI NFV, and we wanted to address these 3 last steps. So if you zoom into the 3 last steps here, the first problem is that far from all deliveries are thoroughly tested, and they're also lacking comprehensive birth certificates as an outcome. And the main reason that this is not done is that it requires very costly field efforts and expensive equipment. So this is typically only done for VIP customers or premium customers. And as a consequence, many deliveries are not tested at all, or just tested using like simple pings from a central location. And clearly, using pings is a lightweight approach. It answers the question if there is a connectivity or not, but it doesn't really answer the question like, can I reach my services? What latencies are seen? Is different traffic prioritized correctly? So this means that a certain percentage of all deliveries are not done right the first time, and faults will slip through. And with an increasing number of changes and deliveries, even this small percentage will result in a substantial absolute number, which drives costs for field efforts and causes delays in delivery times. So our overall goal of the PoC is that all deliveries of services should be tested using software-based agents. And then the second problem is related to the separation between fulfillment and assurance. So while the fulfillment part has typically very detailed information on what has been delivered, assurance, on the other hand, often has a much more limited understanding, and the specific metrics and KPIs to be measured are often added as an afterthought. And what really makes this challenging is when fulfillment makes a change or even an update of an existing delivery. In these situations, it's critical that the assurance platforms also become aware of the new conditions. And with manual work, this would take way too much time, and the separation between these two workflow items would be even more extended. So in order to streamline this workflow, the two components of fulfillment and assurance should be treated together. And that has been one of the goals also of the POC. And the last problem that we identify relates more to the fact that the assurance solutions out there often are based on mapping device-centric counters to customer experience in an indirect way. And this kind of inferring service-specific KPIs is a very difficult task and often results in poor correlation to real customer experience. And as you will hear from Stefan soon, our POC suggests that we should use direct measurements instead on the wire from the customer's perspective. So the opportunity here is to decrease times down to minutes, both when it comes to new deliveries as well as for changes and updates and modifications of existing services that has been already delivered. And the key here, again, is to tightly couple fulfillment and assurance using direct measurement methods from a customer's perspective and drive this whole thing from an orchestrator. And you will now learn how to get there. So, Stefan, please take it away from here.
Okay, thank you, Mats. I would like to go back to the previous page a little bit before I continue here. Note well, there is a big difference in this circle and the straight line Mats previously showed. Note well that we have merged the enable assurance into the overall orchestration flow. It's not something done afterwards. Okay, so what I will go through now is a set of foundations, a set of principles that we've been using both when designing the solution and sketching how this should be done. There was a previous light reading webinar a couple of weeks where I presented what I did call the 4 pillars of orchestration, where one was orchestrated assurance. It's worth noticing that what me and Mats will talking about today assumes the other 3 pillars, because an orchestrator that don't tie fulfillment and assurance together will not solve the issue. I will extremely short mention the other 3 principles that are needed to make assurance to work. The first principle is to use data models and data model mapping. So what we do is that all the services are formally specified in the Yang data model. All the devices are formally specified in the Yang device model, and not only the config part, but also assurance parameters, activation test actions. Those are also formally described in the data models, which means that we can have a data model mapping from the service change to the desired device changes. Moves us to the next pillar. Many orchestration solutions are based on workflows or naive templates. The problem with that is how many templates do you need? How many workflows do you need? Maybe you have one for create and then one for delete, and you miss everything in between. In a dynamic environment, services change, you change parameters, you change costs, you change bandwidth, you add legs, you remove legs. There is constant change in the services. There is no chance for an organization to have enough amount of workflow. So we use a principle we call state convergence, where you just need one workflow definition sort of for the data model mapping, and all the other ones are derived on the fly. Any change are incorporated, and the corresponding diff is calculated to keep the assurance system up to pace with the service changes. And we need to cater both for physical and virtual environments. With those in place, we can do orchestrated assurance, which we're going to talk about today. If you don't have the previous 3 pillars, you're still going to be in problem. And the top level principles we've been having in front of our eyes here is automation, as Mats said, we have automated provisioning and fulfillment. We need to automate activation testing and assurance as well. Second, we have been a little bit too focused historically on the provisioning part. We've done service models for sort of the activation of the service, but we have forgotten about the test case. Good software engineers, if they develop a module, at the same time they develop the test case. We should do the same. If we design the network service, we should also define the test case for it. Thirdly, as Mats mentioned, it's very hard to base assurance solutions on collect whatever you get, device counters, throw them into a big bucket, and hope something useful pops out. That magic mapper. I think we've tried that for 30, 40 years, and we realize it gives us a lot of noise, but it doesn't tell us is the customer happy. So we need to measure service KPIs with direct measurements. Don't try to infer them from noise from the devices. And these two circles, we've been using them in several webinars. I used it in the light reading pillars as well. And this is one thing maybe you should remember from this webinar. I think it's these two circles. They explain most of it. They show a design time aspect and a runtime aspect. To the left, we have the design time aspect, meaning if we do a formal data model for the service, should that service model encounter? Of course, the config piece, that's a no-brainer. That's sort of every service model has the config part. A couple of years ago, we did see more and more virtual stuff. So of course, the data model for the service should incorporate the VNFs, the NSDs, the descriptors, the templates for booting virtual functions. So 1 and 2 comes as no surprise, but what's very important when you do your service modeling is that every service model, every specific service type should have test actions, should have SLA definitions so that you can configure SLA thresholds, should have the most relevant KPIs. And this is, of course, read-only data, so the KPIs that is relevant for the service. And I think it's important here, forget about collecting whatever you can. Think about your service type. Is it video conference, layer 3 VPN? What are the 4 or 5 most relevant KPIs that matters for the end user and model them in the data model? If you have that data model in place, we can move over to the runtime aspect. What happens when the orchestrator drives a service? Of course, it creates the device config. Of course, it boots the virtual functions, number 2. Number 3, once the VNFs are booted, it needs to do the service-specific config on top of them. Then, moving over to orchestrated assurance, don't consider the job done, trigger an automatic activation test. Once that is done, make sure that the orchestrator drives the ongoing monitoring of the provision services. So these two circles are very important to keep in mind when you design your solution. So number 4 being activation testing. Mats mentioned that a bit. Number 5, let me expound a couple of seconds on number 5. What we're doing is actually 2 things. If the orchestrator provisions the VPN, removes a leg, adds a leg, changes quality of service, all of those changes need to drive changes to the assurance system, of course. What is slightly grayed out here is something we don't cover in this webinar, but need to be tightly bound as well, is that all those changes need to update your service impact tools, your service topology, and if you have state convergence in place, you will have all the dynamic changes driven from the service data model being reflected in those sort of classical assurance tools. Classical assurance tools being alarms, inventories, answers, maybe what is broken. That is not the focus of this webinar. We will focus on the top-down thing where you look at the service KPIs and you monitor the KPIs and the SLA. It's more of a top-down thing, and it answers the question, is the customer happy? That is the focus of this webinar here. Okay, so that was a lot of PowerPoint. Does this really work? Yes. What's very important here is that we have running code. You can find the videos where we demonstrate the running code. What we'll go through now is a little bit, how did we make this work? How did we do the Yang data models? How do we design the test cases for the provision services? How do we measure the KPIs? So this is real stuff that can be demonstrated with running code. Okay, what I will do before I hand over to Mats to explain more about the test cases is I will cover should you address modeling your services in the network. And we're using Yang as a formal, semantic, rich data modeling language. And the simple case I will do here is a layer 3 VPN, and we have services over the top there, maybe video conference, for example, over the layer 3 VPN. How can you model that in Yang in order to do both provisioning and assurance? So the coarse-grained, very simplistic view is that you have VPNs. Every VPN has a set of endpoints. From an assurance perspective, each endpoint should have read-only KPI values corresponding to the end user KPI. It should have assurance actions like a activation test or start ongoing SLA monitoring. Talking about SLA monitoring, what you need to cover in your data model is as well, how do you represent SLA definitions? So what we've done in the Yang data model is a model to capture SLA requirements, which are basically thresholds on the KPIs that are read-only values on the endpoints in the data model. And of course, to the left, what's obvious is that the descriptors from the ETSI model, the VNF descriptor, the NSD descriptor, we have Yang data models for those as well. For example, to cover for the virtual test agent, the virtual probes that can do the direct measurements. A little bit deep dive on that. So the purpose of this webinar is to explain that PoC a little more technical in depth. So I spent a couple of minutes to give you an idea on how this looks from a data modeling perspective. Why is data modeling important? Well, remember the principles we mentioned, automation. If you have a formal data model with all data, all KPIs, all actions to do activation test, you can automate. If you stay with Visio diagrams, Word documents, UML diagrams, you need manual steps and you need manual programming. So what's very important with strict data models, it allows for automation, and that is the primary goal. Everything should be automated. With data models, you can parse and automate. Classical software engineering. So the Yang data model for the VPN looks basically like this. You have a endpoint. That endpoint should have assurance actions. So we have actions on your individual endpoint to trigger activation tests, to trigger monitoring. So these are actions in the data model that are sent to the assurance system, which Mats will describe pretty soon here. If you run an activation test on the endpoint, the data model should capture the output from the assurance system to store the activation test results. More, the endpoint should also have the current KPI values, which are of course read-only, and they are fetched from the assurance systems. So these are typical assurance things that historically maybe not have been captured in Yang data models, but it works perfectly. So this is not to scare you, I'm just showing you how it looks like in Yang, is that you have for the endpoint, you have the config false thing, meaning these are read-only values. Then there's a construct in Yang, sort of, which is kind of a macro expansion, where we say for every endpoint, use all the KPI measurements that are available. And here you see the typical ones, the jitter, delay, loss, etc., for up and down. So this is a Yang data model to capture KPIs direct measured by the assurance system, which will be fed by the system Mats pretty soon will describe. Secondly, we talked about the test action, and Yang as a data model language has test actions. So what we can do is that we can have an action on the endpoint that says activation test, takes as an input parameter a named template, and as output we see the result. Did this endpoint work? Is this behaving according to the SLA? And this also needs to be supported then by the assurance system, which Mats again soon will describe. Next. What about the service level definition? So again, attached to the endpoint, what you have there is that two things. You can configure named SLAs. So on the top right here, you have a list of named SLA definitions. You ask the assurance system to drive those. What you will get back to the orchestrator is the current SLA status. So you get that from the assurance system. So on the endpoints, configure which SLA to use, and at runtime, you will have the runtime SLA status good or violated. That is also captured in the same Yang data model. And then on the endpoint here, we can see how that is represented. So I did talk about on previous slide here, sort of the graphical representation. How does that look in Yang? Well, it's fairly straightforward. You configure a reference to a named SLA. So the Yang construct called leafref, that's a named reference, which will point to silver or gold, for example. Then on the same endpoint, you see config false, meaning read-only. Then for that endpoint, you will have the available service level statuses, again, given from the assurance system. The SLA itself then, how do you do that? Well, that's sort of more classical Yang because it's configuration. Because what we're doing here, not for a specific endpoint, but in general, what we're doing here is that we are modeling a list of named SLAs, call them gold, silver, or blue and green. Every service level contains thresholds for the KPIs. Remember, we are measuring KPIs directly. The endpoints have the runtime value of the KPIs, and here we can configure thresholds for loss, jitter, delay, etc., meaning the endpoint can reference the gold or the silver. So that's the way you do the SLA definitions in Yang. The final part, we talked about how do we model KPIs and actions on the endpoint. We talked about how we model configuration of SLAs, also how we have real-time state of the SLAs. Finally, in a virtual environment where we need to deploy virtual probes to do direct measurements, we need to have templates for the virtual probes. And here, for that part, we have a Yang schema that matches the ETSI NFV document, the Mano information model. And at runtime, we apply JSON descriptors to deploy the virtual probes at the endpoint. Here on the screen, you see the virtual firewall. So we have a service chain to the endpoint, can have a firewall and a virtual test probe, for example. So what I did try to show here that you should cover all aspects of the service in one service model, close the gap between fulfillment and assurance, look at the service lifecycle, both aspects. Second, you should have strong, strict data models, not fluffy diagrams, because if you have a data model like this, we can send it to software tools which can automate, extremely important. Secondly, I did show you that we have activation tests embedded in the data model so that we can automate that part as well. Okay, so I hand over you to Mats. How can we make this work? A data model is not enough. We need a backend.
Exactly. So thank you, Stefan. So how do we provide the backend with the capabilities to execute these test actions and the assurance activities that are now being described in the data models? So let us have a look at the key requirements and characteristics for the assurance solution itself. So here's the scenario that we are using as an example in this webinar. So we have a VPN, as Stefan said. We have 3 different demarcation devices. These could be either layer 2 or layer 3. It really doesn't matter for this sake. So the types of demarcations are either a low-end CPE without any test or OAM support. We have a thin CPE in the middle, which has built-in hardware support for reflectors as TWAMP or Y7031. Or we have a more powerful compute CPE, and in the PoC that we did, this was provided by Telco Systems, a distributed VNFI, distributed VNF PoC. And in this overall example, we assume that a virtualized WAN accelerator resides out there on the CPE, and we have also a bunch of virtualized functions residing in the data center, the virtual PE or the virtual router, the virtual firewall, and a virtual SIP gateway as well. And we also included an off-net delivery here. As we all know, off-net deliveries are usually error-prone, and especially if QoS is provided over this path, things tend to go sideways, obviously. And the compute CPE here is a perfect candidate and a target to host a virtual test agent, but more about that in just a little while. So regardless of branch type here, there are three reasons to use direct measurement methods, and I will describe them quickly. So first of all, the first reason for direct measurements is activation testing at the time of initial delivery. And this activation does not only include the carrier grade network level measurements, but also tests through the service chains, all the way from the CPE and traversing the stack of the chain of VNFs in the data center. And by doing this, we also provide a signal to the orchestrator whether or not it's okay to move over to assurance, or perhaps reconfigure or redeploy if something fails. And the second reason here is related to the ongoing SLA monitoring of the KPIs, as was also specified in the model, as Stefan explained. And this provides real-time data, of course, real-time insight that could be used for customer portals or alarms, but also to inform the orchestrator in runtime if some SLAs are violated, so that actions can be taken. And finally, the last reason for this direct measurement is for it's pretty much similar to the activation testing, but this is now when the service is in production mode. As VNFs in the service chain might be upgraded or redeployed or changed, and this will happen at the speed of software, it's crucial to be able to verify these changes at the same level of agility, and this requires direct measurements from the end user's point of view. And all these three reasons for having direct measurements means that we now should be able to design and detail out how to perform these measurements. And this should be done in tight conjunction when we do the service design. As Stefan explained, like this, in the same way when you develop code, you write the test cases and develop the code in conjunction. So let's have a look how we solve this in the POC. Here we have a screenshot from the NetGrounds test sequence builder, where we are building a sequence that matches the service being designed. So we now mix and we pick the building blocks that are relevant for the service in question. So in this case, we start off with this is a VPN, so we start off with an RFC 6349 TCP throughput test. We add on top of that a more service-related test to validate that the SIP media gateway works and the VoIP quality is according to expectations with some HTTP DNS. We even threw in an IPTV monitoring there as well, or testing as well. After that, also validating some specific ports that are relevant for this service, and all these are derived from the model. What was once designed as being the attributes of the service is also now modeled in the testing domain, and we wrapped up with a QS policy profiling test that validates that the right amount of portions in real-time classes, best effort, business class, etc., are the expected ones. And the neat thing now is that this designed test sequence is now wrapped up in a template that is exposed to the orchestrator, with certain parameters as input variables for the orchestrator, such as the SLA thresholds, which test agents to participate in the tests, or even bandwidth or any other parameter that will simplify for usage. So now we have built the actions that the orchestrator could use for activation testing, but also for service lifecycle management. If something happens, if some VNFs are changed along the path, this or a similar sequence could be triggered. But also for monitoring, it's a similar approach. Now we don't build test sequences, but we rather build things endlessly in time. So here we have configured an ongoing SLA assurance monitoring for a number of various UDP queues, HTTP, and some SIP voice, I think it's there as well. And this is also in a similar fashion. It's wrapped up in a template exposed to the orchestrator with a number of parameters exposed. So now we have just going back to the circles again here on the left-hand side, we have all relevant components in the service model, ranging from the configuration and descriptors, as Stefan explained. But we also have defined the actions, SLAs and KPIs, so we can actually complete the service model. And now we can go to the right-hand side to see how can we do this in real life now and do the instantiation. So let's move over to that part of the presentation. So let's start off with what's going on in ETSI, because this was also an ETSI PoC. And in ETSI, there is now an ongoing work that proposes inclusion of using virtual test agents that are under the control and under the command of a centralized test controller, the blue boxes here. And in this PoC, these two components are provided by NetRounds, where Cisco brings their NSO, the Network Service Orchestrator, acting both as the OSS and the NFV orchestrator. Cisco also brings the ESC, the Elastic Services Controller, and the virtual PE router. And at the bottom, Telco Systems, as I mentioned before, bring the compute CPE running on top of Intel hardware. So going back now to these virtual test agents, these virtual test agents can be deployed on the compute nodes, as we discussed before, at the CPE, where we had the NFVI, and as well as in the data center. And as you can see here also, we have also added, in addition to this, a physical x86 running in the legacy world, running the same code on a bare metal machine, just to support this low-end CPE with the testing capabilities. No one really wants hardware boxes out there, but still this is a low-cost, cheap box that could be used in the meanwhile until you have compute devices more commonly distributed. And still in the middle, we have the thin CPE that can be used for reflector support. We cannot cover all the services, but still we can get quite far. So let's see now what we can do. And first of all, we can compare the test agent with the reflectors that are built in. And in terms of network performance, TWAMP and Y1731 brings insight into the classical network performance metrics, such as throughput loss, delay, jitter, whereas the virtual test agent can bring additional insight, especially in terms of stateful TCP throughput, service activation testing in line with Metro Ethernet Forum, as well as on the service layer, IPTV, over-the-top video, SIP, HTTP-based services, etc. So they fill two different gaps here, where the virtual test agent, of course, can do more compared to the thin CPE. So going back to what can be done here, if we go back to the same scenario, we have the test traffic going from the agent to the reflector. So we have the centralized virtual test agent in the data center, sending a reflecting stream in the middle here to the thin CPE. You can measure rate, loss, delay, and jitter. And in the left and in the right spokes here, we send traffic agent to agent. And according to the table in the previous slide, we get even more metrics. First of all, the rate, loss, delay, jitter, but also the more comprehensive tests in terms of stateful TCP and more advanced QoS tests. But this is on the network layer now. But what is also important now, since we are now dealing with service chains, is the next slide, where test agents, note well, we cannot do this from the reflector device, but from test agents, we can also consume services through the service chain. We can measure download rate, we can validate content, we can measure response times, we can measure TCP connect times, etc., and also consume services, either at the data center location or out at other hosting locations. So these two can, of course, be done concurrently in the network layer and the service layer from the virtual test agents. And as a final remark here also is that in scenarios where you have the low-end CPE and you don't want to ship a box out there, then since this is a software-based solution, you can actually put the same software that runs on hypervisors or other x86 targets. You can put them as a bootable USB device, boot up a laptop, and perform the tests from a remote location either to other agents or consuming services from servers out there. So I think this wraps it up, how the tests are being packaged in the sequences or in monitoring and being exposed to the orchestrator. So now Stefan will wrap up and closing the whole circle here through the orchestrator.
Yes, thank you. So that was sort of the technology behind the scenes. I gave an overview of the data models, which are a prerequisite for automation, covering both fulfillment and assurance to do the whole thing. But a data model without the backend is of no use. So for the config part, the classical role of the orchestrator is to do the activation and config. But for the assurance piece of the data model, what Mats explained will enable all the advanced assurance functions we've been talking about here. So, I mean, there is the video, and we have a link to the video in the material here, but I will anyhow explain a bit how it works, and we will share some screenshots with you on how it works. And this is product and running code, so no fake here. Repeating again. So, the next screen where I will show NSO provisioning a layer 3 VPN and over-the-top services. What does the NFV/OSS do? Note well, an NFV orchestrator is just sort of dealing with the VMs. It's not provisioning the complete end-to-end service. So what the orchestrator does in this VPN scenario is, number one, according to the service data model, writes the device config according to the VPN config, so transforms service data model parameters to device config parameters. There are virtual parts here. We have a virtual PE, for example, and most important, as Mats described, we have virtual test agents, virtual probes. So we have descriptors that will deploy the virtual probes in the correct place in the network, and this is extremely important. The problem with classical probes is they're always in the wrong place. If you put them at an office today and then the customer moves, the cool thing here is, since we're using virtual probes and descriptors, the orchestrator sort of sings along and moves the probes to the correct position in the network. We have the state convergence, so whatever change you do, the probes will move. Once they're up and running, we write the service-specific config, both for the probes and for the virtual PEs, etc. And the orchestrator, the NSO, asks the assurance system for NetRounds, please verify this VPN. Also, please verify this over-the-top service. We've done the config is fine, but does it work? So based on the data model, we drive the activation testing. Once that is done, we hand over to constant SLA monitoring. So we configure the assurance system. Here's the VPN, here's the endpoints, here are the SLA parameters. Please measure the KPIs directly and match them against the SLA. So this is the circle, and this is the way it looks like in NSO. So what we have here, if I concentrate on the right part illustrates a leg in the VPN. So to the far right, there is the CPE, and what we have, sort of the layer here, if you click on the layers here, you can see assurance information. So the top red circle is that the SLA is violated. So we've asked the assurance system, please monitor the SLA for this endpoint in this VPN. Then also we have the green thing indicating we did run an activation test when we orchestrated this service. What the outcome of that activation test? So you see here in the orchestrator we have SLA information, we have the history of activation tests that we have run. You also see a mouse over thing, so we can, yes, the data model, you remember, we had the runtime values for the KPI. So for this endpoint, if the customer calls, we can see the current service-specific KPIs, both for video and networking in real time. And remember, this is direct measurements. It's not something where we fetch data, we do some processing, and we're guessing and we have some values later. These are real-time measurements, constant ongoing. That's the sort of assurance side. the square things here in the orchestrator, we opened up, that corresponds to a network service in the monolingual. So here we booted a virtual CSR and, extremely important, the virtual test agent. So without booting virtual test agents in the correct place in the network, this would be very hard. So this is what the orchestrator drives, and this is what is available in the NSO UI, fed by the backend from the assurance system. And Mats will show you a couple of screenshots from the SLA monitoring and activation testing, etc.
Yes, thanks, Stefan. So the next slide is just a quick overview of what is available through direct links in the NSO as well. So as soon as there has been an activation test executed, it's also possible just to navigate and drill down directly into the details if that is relevant. And you can even have the instant test results and protocols sent out to the customer that is expecting this delivery to take place. And even in assurance that's ongoing, as Stefan showed, the NSO shows the real result in real time that is being grabbed from the assurance system. You can also drill down and find out what is actually the current status of the SLAs at the moment. So that's it, I think. And Stefan, the summary and key takeaways here.
Yeah. So remember the three principles we mentioned initially and been trying to sort of repeat. And automation, I mean, automation is nothing new. We've been talking about automation for years around provisioning. We talk about automation in software development. And we've been a little bit bad on automation in OSS, I would say, especially in assurance. And in our experience, you need something to automate on. Automation assumes software. Software assumes formal input, and that is data model. So if you have a formal, strict data model, you can automate everything you've seen here. Without strict data models, you're back to extremely expensive and tedious professional services integrations. So data models enables automation. Secondly, test-driven design. If you design a service, you're not done until you have defined a test case for it, and don't stay with simple pings. I mean, modern services are fairly complex, and the Mats did show the kind of KPIs you can measure. So make sure you have real tough test cases for your service and require the orchestrator to drive those as part of the provisioning process. And third, direct measurements. I have a previous history in the assurance business, and I'm extremely sort of fed up with all the collecting whatever you get approaches, and maybe we can calculate the service KPI as an afterthought. That I think it's very hard to achieve true service KPI. So forget that principle. What are the most relevant KPIs for your service and measure those directly. Stop the crazy collect whatever you have and maybe you find something. Okay.
Well, thank you both very much for that presentation. That was wonderful. We do have a couple of questions from the audience that have been submitted. And for our viewers, once again, if you do have any questions, please go ahead and submit those now. And if we don't have time to answer them, we will follow up with you offline. So thank you for those. Our very first question is, how does the orchestrator communicate with test agents?
Okay, I think I can take that one. So just to clarify, the orchestrator will not communicate directly with the test agents. That's not the idea here. The idea is rather to have test controller. If you remember the ETSI architecture, is the idea to have a test controller providing an abstraction to multiple numbers of test agents. You could even imagine a VPN with hundreds of endpoints. It will quickly become quite complex to coordinate this and then schedule this. So this is offloaded to the test controller. So there is an interface from the orchestrator to the test controller.
Great. Our next question from the audience is, what about big data? Will this not solve the assurance function?
No, sure. Big data will not solve the whole thing. Some people do a lot of hand waving, throw a big data, and assurance will be solved. That's not the case. I mean, if we today have device counters in an SQL database and do SQL reporting, if we replace that with a Cassandra database, we still have the same problem. Someone needs to write the MapReduce functions for you. And I mean, of course, statistical approaches are more useful in big data. But the fundamental principle has nothing to do with big data or not. Measure the KPIs directly. You need to measure loss and jitter in a direct way. Yeah, throw that to a big data database. That will enable a lot of cool things, but you need to have the service KPIs directly measured. The big data database will not give you those KPIs based on device counters. There's no touch-free lunch.
Thank you. So we do have time, it looks like, for at least one more question. So the next question is, would I need one test agent per service?
I think I can take that one. I think it depends on the manufacturer, of course, of the test agent, how they what kind of tool set they bring into it. I can just speak for Netron since I'm a representative there, and we have squeezed in a lot of various capabilities ranging from the network layer up until the application layers, including IPTV or the top video SIP, etc. So I think that it depends on which kind of test agent there is.
Great. And we have one final question for you, Stefan, which is why Yang? Is that not the only device configuration?
Well, if you look at the history of Yang, I can understand the question. I mean, it was originally defined by IETF because we needed a data model for device config. We all did know that SNMP is good for monitoring, but we need something that can deal with device config. So that's the history. So the question is relevant. But the thing with Yang is a very strict and rich data modeling language. So it works perfectly for device config and device monitoring. Perfect. And there is no limit if you want to model a device or a service. It works perfectly fine for service as well. And as I did show, it works fine for the templates from Mono as well. So it's a general purpose, but still very precise and specific data modeling language, which allows for automation. So it proved in this POC especially to be great for this purpose.
Great. Thank you very much. And thank you both for joining us today. We are out of time. Do you have any last closing remarks? And could you please tell the audience the best way to connect with you offline?
Matt, you.
Stefan, you can reach me at the matt.nordlund@netrons.com. Feel free to reach out with any questions related to test controller, test best practices, or anything related to performance issues in networks.
Yeah, and you can reach me at svallin without a dot, svallin@cisco.com. Thank you for joining.
Thank you for joining, and thank you, Lindsay, for hosting us here.
Thank you.
Bye-bye.